You step outside one morning, ready to soak in the warmth of the sun, just like Todd. But it suddenly hits your face and blinds you, and makes you grouchy. You wished it was replaced with something else. Congratulations, genius. You wished for something more exciting than the boring old sun. An extreme space object wandering the universe like it lost its GPS. And now it's decided to crash our solar system. Hope you packed your SPF Infinity because sunscreen isn't saving you this time. But wait, we are not going to replace it with just another star. We will have some fun and see what happens when we replace it with the most extreme space objects in the universe. And stop looking at me like you look at your girlfriend, Todd. I had been on a vacation with my girlfriend after we have covered space objects' ultimate cosmic fight in our previous episode, and I got this tan. Isn't I am looking hotter than your girlfriend? All right, let's start simple. Imagine we replace our sun with a red dwarf star. Sounds cute, right? Like a cosmic pet. Except this pet barely glows, spits random flares like an angry toddler. A red dwarf star is a small, cool, and dim type of star, and it is the most common type of star in the Milky Way. These are smaller and less massive than the sun, with a mass of approximately 0.08 to 0.6 solar masses. They are the longest living stars, with lifespans that can reach up to 12 trillion years. This is because they can use almost all of their hydrogen fuel. The closest known red dwarf star is Proxima Centauri, located about 4.25 light years away from Earth. If this were our new sun, Earth would instantly freeze. Oceans, ice cubes, crops, dead. And you? Congratulations! You just unlocked the frozen popsicle achievement. Seriously, you'd be better off microwaving yourself just to stay warm. But hey, at least you'd finally save money on sunscreen. Too bad you'd be saving it while shivering in a snow-covered wasteland, eating, oh wait, nothing, because plants can't photosynthesize in the dark. Smooth move, buddy. If frozen death wasn't dramatic enough for you, let's crank the thermostat up. Meet the blue giant, Alnellum. Blue supergiants are incredibly large, with masses up to 100 times that of the sun. They are extraordinarily bright and emit intense heat, with surface temperatures significantly hotter than the sun. But they have a short lifespan, often lasting only tens to hundreds of millions of years before exploding into a supernova or collapsing into a black hole. The closest known blue supergiant to Earth is Rigel, located approximately 860 light-years away from Earth. Swap the sun for this blue giant, basically the cosmic equivalent of sticking Earth in a nuclear oven set to extra crispy. These monsters shine hundreds of thousands of times brighter than the sun, and burn so hot that stepping outside would feel like standing beside a flamethrower convention. The oceans wouldn't just boil, Todd, they'd evaporate. Think of it as the world's worst sauna ruining our little family reunion. And you? Well, let's just say you'd become a piece of charcoal faster than your mom's famous holiday turkey.
Okay, Todd, you clearly weren't satisfied with being a popsicle or a barbecue snack, so let's go full overkill. Say hello to Betelgeuse, a red supergiant. This is a massive aging star that has exhausted its core hydrogen fuel, causing its outer layers to expand dramatically and cool, resulting in a red color. They are enormous, with some being over 1,000 times larger than the sun in radius. Swap the sun for this red supergiant, one of those absolute cosmic units that makes our sun look like a flashlight. These stars can be over 1,000 times wider than our sun. The moment it arrives, Earth isn't orbiting around the star anymore, it's inside it. And don't even think about moving to Mars. Mars is gone. Jupiter? Gone. Pluto? Don't make me laugh, Todd. However, If we find a way to move humanity to Pluto first, we would be able to survive for about a week and get a decent amount of time to enjoy our vacation with our girlfriends in its toxic atmosphere. And of course, you both will need these spacesuits to survive, except for me and my girlfriend. After the week has gone by, let's be optimistic. The star's heat will murder you. Then gravity will suck you in like all the other planets and destroy everything you have ever known. The only thing you'll be orbiting is your regret. Oh, but it gets better. When these stars run out of hydrogen in their core, they die slowly. When this supergiant finally dies, it doesn't just explode. No. It goes hypernova, an explosion 100 times more energetic than a supernova. The shock wave would shred Earth into atoms before you even said, well, at least it's warm. Todd, you survived the galactic barbecue somehow. Fine. Let's replace the sun with a neutron star. Meet PSR-J0737:39b, basically the burnout corpse of a massive star. If the remaining core is more massive than about 3 solar masses, it will collapse further into a black hole instead. Sounds harmless, right? Wrong. These neutron stars are typically only about 12 miles or 20 kilometers in diameter and possess extremely strong magnetic fields, billions or trillions times stronger than Earth's. They spin incredibly fast, with some rotating hundreds of times per second. The closest known neutron star is RxJ 18565-3754, located in the constellation Corona Australis, approximately 400 light-years away. This cute star is the size of a city, but it has the mass of our sun crammed into it. That's like stuffing an elephant into a soda can and then throwing it at your girlfriend's face at light speed. Because these are so small and we can't see it from Earth, so everyone on Earth would think, okay, no heat, I guess we just freeze. Well, yes, sometimes, but no. Gravity here is so intense that every plant will have a stable orbit. It will make the average Earth temperature so hot that Earth will turn into a desert with nothing to eat. I hope you like to sweat, Todd, to maintain your bad fashion sense. And also, gravity here is so intense that if a small object dropped on its surface, would slam into the surface with a force of a nuclear bomb. And you, Todd, you'd be stretched thinner than your thin hair. Oh, and don't think you get a cold, peaceful death either. Nope, this star blasts lethal radiation like it's spraying Febreze. You would be squeezed to your worst nightmare instantly. And if that wasn't enough, sometimes these stars get an upgrade, a magnetar. These are a type of neutron star with an extremely powerful magnetic field, up to 1,000 times stronger than typical neutron stars. These objects are the most magnetic known in the universe, and their decay can release intense bursts of high-energy radiation, such as X-rays and gamma rays, often triggered by starquakes or magnetic field instability. These bursts are powerful enough to be detected across the Milky Way and can release more energy in a fraction of a second than the sun emits in 100,000 years. A magnetar's magnetic field is so strong that within a few hundred miles, it can distort atoms into rod-like shapes, tearing apart the molecules that make up matter. By far, we have managed to detect a magnetar, XTE J1810197, near to our Earth, located approximately 8,000 light-years away. These neutron stars' magnetic field could erase your TV before you finish saying, wait, where's my girlfriend? Still, these nightmares are not enough for you? What about a pulsar? A rapidly rotating, highly magnetized neutron star that emits beams of electromagnetic radiation from its magnetic poles. And if a beam were to hit you, every part of your body would be flash radiated.
Okay, Todd, let's ease you down. You've been frozen, fried, and stretched to hell, but let's stop playing around and bring in the final boss, a black hole. Say hello to Cygnus X1. At first you might think, oh, hey, this isn't so bad. No blinding light, no fire, no radiation. Cute. Except you forgot the part where black holes eat literally everything.
A black hole is formed when a massive star collapses under its own gravity, compressing all its mass into an infinitely dense point called a singularity. The boundary of this region is called the event horizon. These have masses up to about 20 times that of the Sun. And we have actually discovered a black hole closest to Earth, Gaia BH1, located approximately 1,560 to 1,600 light years away. It exists as part of a binary system. That means it's orbiting a star similar to our boring sun. But the second this thing strolls into our solar system, it's game over. Sun, gone. Other planets, they're lining up to get eaten one by one. Oh, and you're getting stretched again. Not the nice kind you were before, Todd. The horrifying kind physicists call spaghettification. Imagine being pulled apart piece by piece until you're inside this beast. But now you're thinking, what if it's just a small black hole, same mass as the sun? Fine. Earth would keep orbiting in total darkness, which means no crops, no warmth, no light, just you and your flashlight, Todd, until the batteries die, and then so do you. Oh, and if it's a supermassive black hole like Tom 618, which have mass millions or billions of times that of the sun, forget spaghetti. The entire Milky Way gets vacuumed into oblivion.
Just when you thought Todd couldn't possibly die in more creative ways, here come the ultimate mythical boss monsters of astrophysics. Meet quasi-star. These things were hypothetical and probably born in the early universe. Quasi-stars are thought to have formed from the collapse of massive primordial gas clouds in the very early universe, a few hundred million years after the Big Bang. These stars are so massive that its core collapses to form a black hole. Despite their immense power, they have a relatively short lifespan, lasting only a few million years. They have a radius of up to 10 billion kilometers. In Megaton 1 and 18 and Betelgeuse look so small. Imagine a star 1,000 times the mass of our sun, with a black hole hiding in the middle, eating it from the inside out. If we put that where our sun is, well, basically the same thing would happen as Tonsorians, but perhaps with a more nastier death due to the star's hydrogen and plasma around it. But maybe you're thinking, okay, fine, that's too rare. What's next? Oh, no. Todd, meet the strange star. A strange star is what happens when a neutron star collapses into denser, made of strange quark matter. And it's just a tiny chunk of strange matter touched Earth. It could theoretically turn the whole planet into strange matter too, meaning Earth would transform into a horrifying quark blob in seconds. Congratulations, Todd. You're now literally made of the same stuff as a physics nightmare. So yeah, replacing the sun with extreme space objects means Earth gets roasted, frozen, or worse, turned into my ugly wife. But here's the real question. What if, instead of swapping our sun, something out there tries to steal it?